Hi there to whoever is watching. This is going to be a real quick overview of the online safety valve testing method. I was informed that you guys have a couple of concerns, a couple of questions about this method, so hopefully this video clears everything out. Okay, so real quick, I want to talk about what we want to do. So imagine you have a valve, okay, and a safety valve, and you want to see at what point does the safety valve open. Now, it's quite easy to understand how this valve works, right? So you have a spring, okay, and this spring has some compression force, and this force is downwards, which means when you apply pressure here, it will not open instantly. The pressure should increase enough to surpass the compression force of the spring here, okay? So we need to increase the pressure more and more and more until we surpass the force of this spring. Okay. Okay. So this is usually done on a bench. You will install this on a bench machine and you will apply force. You will apply pressure until the valve opens, and you'll record this point. Okay. So this is one way of doing it. Another way is to keep this inlet pressure same. Okay. Not touch this one. Instead, you'll grab this spindle and pull upwards. And at one point, it will open. The valve will open because you're pulling it upwards, right? So at one point, that point means the pulling upwards force plus the pressure from the nozzle, from the downside, from the inlet, both of them were able to open the valve or surpass the compression force here. Okay. Which means you can take a point, you can take a note of this point, and you can find out the P opening or the pressure opening of the valve, okay? Opening point of the valve. You can do this. Usually we have force sensors installed, and we clamp the spindle and we apply upwards force, and this way we know exactly at what force the valve opens. We know at what point exactly the valve opens, but we know the force, we don't know the pressure yet. Okay, so here, as you can see, you are applying upwards force. Okay, and there's also some pressure in the line on the inlet of the valve. So P line, pressure of the line, plus this force that you're applying, both together will surpass uh, the the spring compression force, and the valve will open. Okay, but obviously what you want to know is you want to know P opening. Okay, you want to know at what point does the valve open. Yeah, that's better. So you want to know at what point does the valve open. So to do this, you need to know the remaining pressure until you arrive at the opening pressure or at the set pressure. You need to know that. But with this method, if you have a force sensor, you know the force, okay? You know at what force the valve opens, but you don't know at what pressure. But remember, force divided by area is pressure. So if you know the area of the seat or the area at which the force is applied, you can just divide the opening force by the seat area. You will get the remaining pressure, okay? So that's why you see here we say F opening divided by seat area plus the line pressure will equal to the opening pressure of the valve, okay? Which is uh, which is which should be the set pressure, okay? Should be near the set pressure at least. Okay, so this is the basic principles. This is the basic principles. Now, obviously, force is easy to get because you have the force sensor. Remember, we have this force sensor here, so it's very easy to know at what force the valve opened. But what about the seat area? So the seat area you also need to know to be able to do this method or utilize this method. In many cases, seat area can be found on data sheets or in databases, or can be estimated very accurately using the nozzle size and the valve size and the orifice size and stuff like that. It can be estimated. But in some cases, in some rare cases, with some valves, we don't have these seat areas saved in our databases. And it's not it's not a good practice to always come up with estimates only. Um, so that's why there are other ways to do this also to measure the seat area. So one obviously is to open the valve up and manually measure the seat area using calipers and calibrated measuring tools, right? This is one way, obviously, uh, which is not always utilized because the valve is installed. You don't want to open the valve while it's in service. You don't want to put it away from service even for a minute. Okay, so that's why this method is not utilized quite a lot, but it's utilized in certain cases. Okay, certain cases it is utilized. Another way to measure this seat area, which is very interesting, which can be done with our Liga test machine, okay, is the two test method. So we test the safety valve with two different line pressures, and then we're able to get the seat area. Okay, so I'll show you guys how this is done. Now, you run your first test. Okay, we run the first test with, for example, let's say 80 bars. Okay, P line 1. We run the test. We get the opening force. Okay, we get opening force 1, and seat area we don't know, is unknown. P line we know, and P opening we don't know because we don't know what's the seat area, so we cannot divide these two and add the P line to get the P opening. So we don't know what's the P opening. Okay, okay. And then what we do is we change the line pressure. So from 80 bars, let's say we change it to 77 or 75 bars. Okay, and we run the test again. So this is the second test. Okay, so P opening 2, or the opening pressure for the second P line, which is 75 bars, for example, let's say. And we measured again with the force sensor the opening force 2. Okay. Yeah, so this is test 1, this is test 1, and this is test 2. Now, there's one thing to note here. This is one valve. No matter what the pressure line is, the opening pressure of the valve is same. It will not change the opening pressure of the valve. So if the set pressure of the valve is 75 bars, it will open at 75 bars, no matter what the line pressure is. Even if the line pressure is 10, the valve still has this property of opening at 75 bars. So we know no matter what the pressure line we changed, P1, P opening 1, and P opening 2 are equal. So P opening 1 equals P opening 2. So this means one unknown is automatically gone, right? So we're going to set these two. We're going to set P line 1 plus F opening 1 over seat area equal to P line 2 plus F opening 2 over seat area. So these two are equal now. And you can see from here, we know P line 1, we know P line 2, F opening 1 and F opening 2 are measured using the force sensor. The only unknown we have is seat area. So we just have to rearrange this equation and get seat area. So it's quite easy to do this. We'll send this guy to the other side and send this here. So this is what we're getting. And later we combine these fractions. This is what we're getting. We're going to divide with F1 minus F2. So when we divide by that, we get this one. We take reciprocals here. So we basically take this up and take this up, take this down. So this is the equation we get, okay? So all we have to do to get the most accurate seat area is to test the valve with two different line pressures, and then we can easily calculate the seat area. And this was given in the procedure we provided. So let me real quick show you the procedure. Yeah, this one. So if you see here, okay, this method was given, and the same equation is provided also. Okay. Okay. Yeah. So as you can see, just like we said, we will test once with one system pressure. Okay. So system pressure 1, we will get the force, and then system pressure 2, and we will get the second force, and then we can just put it into this equation and we'll get the area, the seat area. Okay. Now, obviously, this is done in the software automatically. Let me real quick show you guys. Okay, so for example, let's open this one up. Okay, so you see it's done in the system automatically. So we'll choose this method of calculating the seat area, which means middle seat area from two measurements. We will give system pressure 1, system pressure 2, opening force 1, and opening force 2, and then it will automatically calculate for us the area in centimeters square. Okay, and this one obviously also uses the same equations and same stuff. It's just easier. It's a system that calculates this for you. Okay, so hopefully that clears how we can accurately measure the seat area. Now, you see the data sheets for your valves, SV, V series, star steam. We already have technical information for this valve. We already know the orifice diameter of this valve, which is 95.3 for letter Q. This one is letter Q, I suppose, right? Orifice letter Q, yeah. So orifice letter Q. This is the diameter. Okay. So if you have the diameter, area calculator, circle, you can easily get the area. So let's just do that real quick. Okay, so the area is 95.3 we set. So the area is 71.33 centimeters square. Okay, which means this is a very good estimate of your seat area. But if you want a better estimate, and if you want to make sure at least, you can do the two measurement method. So it's up to you if you want to continue with this one or proceed with the two measurement method. Okay. Yeah. So that's that. Okay. Now another question that you guys had was the force that we need to apply on the spindles. Okay. I can relate to why you're asking this question, and obviously nobody wants to apply a lot of force to their spindles up to a point where you break the spindle up. Okay, so I'll show you guys real quick what will be the force we need to apply for this specific safety valve. Okay, so you see the set pressure is at 100 for this valve, and the operating pressure or the line pressure is 91.2. Okay, so real quick, let's do 100 minus 91.2 equals 8.8. So we need 8.8 more bars to open this valve. Okay, 8.8 more we need. Yeah. So, but what force we need to apply to get to this point? What force we need to apply? Since I know the seat area, or I know the orifice area at least from here. Okay, the seat area very similar to this. Okay. Since I know that, and I know the pressure that I need to apply, which is 8.8 bars, I can just use this website and calculate this. Okay, so this is 8.8 bars I'm gonna apply. I need to get to, and the seat area is 71.33 centimeters square. And let's get the force in kilonewtons. Okay, so you see the force we need to apply for this one is 6.27 kilonewtons. Okay, 6.27 kilonewtons. Let's increase the seat area more just to give it some room. So 6.3 kilonewtons, let's say. Okay, so maximum we will be applying is 7 kilonewtons in any case for this valve here. Okay, for this valve here. Now I can do this for all the other valves that you have, but obviously it doesn't make sense to do this for all of them. You know now how it's done, so you can just take a look at them and see what force is needed to be applied. Okay. Anyways, so hopefully that clears everything out. If there's anything else that I can help you with, please let me know. Thank you. Cheers. Bye.